Hey guys, now that we've gone over what the limit definition of derivatives actually is, let's go ahead and practice applying it. So we have it written out here. To find our derivative, that's our f dash x, we take the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Now you'll see when we start to apply this that we can't just plug in 0. Remember, that's usually our first step to see if we can solve the limit. You just plug in whatever the x, or in this case delta x, is approaching. That would give us a 0 in the denominator, so we're going to have to do a little more simplifying to get this to work out. So let's practice plugging in our function f of x equals 2x squared plus 3x. You're going to treat this f of x plus delta x section just like you would any other input. If I asked you to plug in f of 2, you would just replace all the x's with 2's, right? So we're going to follow that same idea just with x plus delta x. So let's go ahead and start. So we want to find our derivative. Rewrite our limit as delta x approaches 0. And for our first section, f of x plus delta x, that would be 2 times x plus delta x plus 3 times x plus delta x. And that's our first section. And then minus f of x, that means we just rewrite the whole f of x function. And don't forget your parentheses because you're going to want to distribute that negative. And then on our denominator, all we have is delta x. We'll leave that the same for now. And let's not forget our square up here. So once we've written all that out, we need to go ahead and simplify by distributing first and then seeing if there's a way we can cancel out that delta x in the denominator. So let's start by distributing everything. So we want to FOIL out our x plus delta x, and then we'll distribute that 2 in, and we want to distribute our 3 and our negative. Let's go ahead and do that. The limit as delta x approaches 0, remember to always rewrite that until the very end when we plug in our value. So we'll start by FOILing out x plus delta x. We would end up with x squared plus 2x delta x plus delta x squared. And then we would distribute that 3. We would have 3x plus 3 delta x. And then distribute that negative. We would have negative 2x squared minus 3x. And then on our denominator, we would still just have our delta x for now. So let's go ahead and distribute that 2 in, and then we'll look around, see what like terms we can combine, see how else we can simplify everything. So we'll distribute that 2, and we have 2x squared plus 4x delta x plus 2 delta x squared plus 3x plus 3 delta x minus 2x squared minus 3x. As you can see, it's kind of a mouthful. It's a lot of algebra with these types of problems of plugging stuff in and simplifying. But once you get the hang of it, it's not too bad, and thankfully we're going to learn some shortcuts for derivatives soon. So once we're at this stage, we want to go ahead and find any like terms that we can combine. So we can combine that positive and negative 2x squared, and they'll cancel out. Let's see, we have a negative 3x and a positive 3x. Those will cancel out. And then everything else, we'll just go ahead and rewrite that and see what we can figure out. So now we just have 4x delta x plus 2 delta x squared plus 3 delta x all over delta x. Now we can go ahead and simplify this by crossing out all of our delta x's because we have a delta x in the denominator and a delta x in each term in the numerator. So we can go ahead and cancel that out. And I'm actually going to go ahead and move our on your own problem to a bit farther down to give us a little more room. So back to up here, once we've canceled out our delta x, we have the limit as delta x approaches 0. Now we just have 4x plus 2. We still have another delta x there because that's delta x squared plus 3. Now we're going to evaluate this limit by plugging in 0 for delta x. We have 4x, so that stays the same, plus 2 times 0 now, plus 3. And if we go ahead and evaluate that, our final answer would just be 4x plus 3. And that would be the answer for our derivative. So that 4x plus 3 is our derivative of 2x squared plus 3x. And we found that using our limit definition of derivatives. So let's go ahead and see if you can do this one on your own. So pause the video, take a few minutes, see if you can figure it out. Alrighty, so let's go ahead and do it together now. So our first step is going to be to rewrite everything with our limit as delta x approaches 0. And remember, our limit definition, our first step is to plug in f of x plus delta x. And that's going to be our first term in the numerator. So let's go ahead and do that. If we plug in x plus delta x wherever we see an x, we would have 3 over x plus delta x. And then minus f of x would just be minus 3 over x all over delta x. So this one looks a little bit messier than the past one because we're working with some complicated fractions. So remember that when we're working with fractions with different denominators, our first step is going to be to try to get the same denominator so that we can combine them and get rid of any extra fractions that we're working with. So what we're going to do here is we're going to multiply the 3 over x plus delta x by an x on the top and the bottom, and our negative 3 over x by a x plus delta x on the top and bottom. And you'll see what that does is that'll give us the same numerator, or the same denominator, and we'll be able to combine our fractions. So now, once we do that, we have a 3x over x times x plus delta x minus 3. We want to distribute that to the x and to the delta x, so we'll say 3x plus delta x, and we'll distribute that negative in a second, all over x plus delta x, all over delta x. So, alrighty, it's still looking a little bit messy, but we can go ahead and continue simplifying, and we'll get to it looking a little bit better soon. So we want to do a couple things. We want to put all of this in one fraction, so we'll start by combining those top fractions into 1, and we also want to distribute that negative to both 3x and to 3 delta x. So we have our limit as delta x approaches 0, and now we have 3x minus 3x minus 3 delta x all over x times x plus delta x all over delta x. So we can combine this into one fraction by putting the denominators together, and we can also simplify this by crossing out our 3x minus 3x. So let's rewrite that. So now we just have a negative 3 delta x in the numerator, and our denominator has a x times delta x times x plus delta x. We're getting close to the finish line here. The next thing that we want to do is cross out that delta x now that we have one in the top and in the bottom. So now we just have negative 3 over x times x plus delta x. And we're almost done here. We can go ahead and plug in 0 for our delta x because it's no longer going to give us just a 0 in the denominator. We're going to end up with an x squared. So we can go ahead and plug in 0, which means we can drop our limit notation, and we'll say negative 3 over x times x plus 0. X plus 0 is just x, so that's negative 3 over x times x, which is x squared. And that would be our final answer, so that is our derivative for 3 over x. Alrighty, thank you for watching, and I hope this helps.